In this video, we're going to graph a system of linear inequalities. And remember, a system means two or more linear equalities with the same variable. So we're going to be focusing on those linear inequalities, the ones with the dotted lines or solid lines and the shading. And there will be two or more that we will put on the exact same coordinate plane. So in this lesson, if you know how to graph a linear inequality, you know how to graph a system of linear inequalities. So what we're going to do is you'll notice here that we have two inequalities. We have this first inequality here in red, the second one here in blue. And what we're going to do is we're just going to graph them one at a time. And remember that in order to graph them, we need to rewrite them into slope-intercept form, or essentially y equals mx plus b form. So we're going to start with this first inequality, and we're going to start by adding 1x to each side. Because in doing so, we're going to start getting this y value alone so that we can find its slope and its y-intercept. So here I would then have 2y is less than or equal to 4 plus 1x. We then divide everything by 2. So we end up with y is less than or equal to 2 plus 1/2 x. So then from here, I know that my y-intercept is 2 because that's my constant value. And then my slope is 1/2, which means we're going to go up 1 and then to the right 2. So up 1, right 2, up 1, right 2, up 1, right 2. And then I can repeat that same pattern backwards. Then from here, I note that I have an inequality that has an equal to underneath. And as a result of that, we are going to have a solid line. So I can connect all of my dots with a solid line. And then the last thing I need to determine is which way I am going to shade. And here, I'm going to just test a point to figure out which region, region 1 or region 2, is going to work. So here, I'm going to test the point 0, 0. And if it works, that tells me that that region should be shaded. And if it doesn't work, that tells me that the other region should be shaded. So I'm going to substitute it back into that inequality. So I'm just going to substitute it right back into here. You can also put it back into your original. It doesn't matter. And here I substituted in 0 is less than or equal to 2 plus 1/2 times 0. So I get 0 is less than or equal to 2, which I know to be true. So what that's telling me is that region 1 doesn't work, but this region down here in region 2 with the point 0, 0 does work. So that's the direction I'm going to shade. I'm going to shade that all in there, make that circle just a little bit bigger, make my shading a little more efficient. I need to shade every single point that I can see here in region 2. Okay, so now that I've graphed that first inequality, I'm now going to focus on my second inequality here. So I notice that to get y alone, I need to divide both sides by a -3. And because I'm dividing both sides by a negative, I'm also going to have a sign flip. So here I have y is greater than 6 divided by -3 is a -2. And then here, if I use keep, change, I see that I have a negative over a negative, which is a positive 4/3 x. So there I have my inequality, so I'm going to move and graph. So I go to where my y-intercept is -2. And then to follow my slope, I'm going to go up 4 and then to the right 3. So up 1, 2, 3, 4, right 1, 2, 3. Up 1, 2, 3, 4, right 3. Then from here I note that I don't have an equal to underneath my inequality. So what I'm going to do then is I'm going to have a dotted line connecting all of my points. Then I'm going to apply the same pattern backwards. So I would go down 4 and backwards 3. So I get an additional point there. So now my last step is to decide which region I want to shade. And notice here that I have region 1 here and region 2 here. So I'm going to have to shade one of those two regions, and in order to figure out which region I'm going to shade, I'm going to test the point 0, 0. So that point is right here, that's in that first region, and I'm going to test that point out. So I'm going to substitute it back into this inequality. So here I have 0 is greater than -2 plus 4/3 times 0, which gives me 0 is greater than -2, which is true. So what that's telling me is I want to shade above that line in region 1. So here I'm shading. And what you should be noticing here is I get this region that's a slightly different color. So I'm going to kind of put it in black here to make it a little more obvious. But this region right here that I'm highlighting, this region, notice how there's an overlap there. So this region right here is our overlap region, right in here and then beyond. And this region right here consists of points that work in both linear inequalities. So when we're graphing linear inequalities, we're looking for this multiple shaded region that consists of points that work in both inequalities. So just like when we solved a system of equations, we found the point that worked in both equations. Now we're finding points that work in both inequalities. And any point in this black region will actually work in both of those inequalities. So in example 3 here, you'll notice that we have 3 inequalities. And what we're going to do is we're going to go through this exact same process. We're just going to graph one inequality at a time. And then because we have 3 inequalities, we are going to look for that triple shaded region where all 3 inequalities have points that make the inequality true. So to start, we're going to look at graphing inequality 1. So we're going to start by graphing the inequality of y is greater than or equal to 1. And what I like to do for these single variable ones is pretend for a second that I have y equals 1 to help me get a general idea of what this inequality's line is going to look like. So here this is telling me that y is always equal to 1 and that there aren't any constraints on x. So I can pick whatever I'd like. I'm going to just pick 2, 0, and -2. And then if I go over to my graph and I plot these points, what I find is as I plot these points, I have a horizontal line. And then if I look back at my inequality, because I have that equal to underneath, I know I'm going to have a solid line here at y equals 1. Now at this point, I need to determine which way I'm going to shade. And in this particular inequality, I want to shade where all of the y values of the points are greater than or equal to 1. And so what I see here is that greater than or equal to 1 are all of these points here above the line. Here's where, y is between 1 and 2, 2 and 3, 3 and 4. So all of these points upwards have y values that are greater than or equal to 1. And you can also use the test the point option. That works as well. But here we can just clearly see this is where the y values of points are greater than or equal to 1. It's where the y-axis, those values are greater than 1. Now if I switch gears here, I'm going to now focus on x is greater than 2. And just like before, I'm going to start by pretending there's an equal sign there so I can get an idea of what this graph's line is going to look like. And here, what this is telling me are that my x values are always 2, and my y values can be whatever I want. There's no constraints on y, so I'm just going to pick -2, 0, and 2. And then if I go over to my graph, I can start to plot these points. And what I notice as I do this is that my points form a vertical line. Then from here, to determine what type of line, dotted or solid, I'm going to draw, I look at the inequality and I notice that there's no equal sign underneath. So we're going to draw a dotted line here. And then from here, I need to shade in the direction where x is greater than 2. And I know that if I look at my x-axis here we have x is 3, 4, 5, 6, etc. So I know that I'm going to shade to the right of that line. That's where x has values for points that are greater than 2. So I'm going to shade this entire section here. So what we notice here is we have this double shaded region right here in the upper right-hand corner of our graphs. So now as we graph our final inequality, what we're going to be looking for is that triple shaded region. So here, because I have two variables, I'm going to start by subtracting x from each side. So I have 2y is less than or equal to 8 plus a negative 1x. Remember, there's really a 1 in front of here. And then I divide both sides by a positive 2. So I have y is less than or equal to 4 plus a negative 1/2 x. So now I go over to my coordinate plane with a y-intercept of 1, 2, 3, 4. And then my slope is going to go down 1, right 2. So I go down 1, right 2, down 1, right 2, down 1, right 2, and then I can continue that same pattern backwards. Now from here, because I have the equal sign underneath, we're going to draw a solid line. And then from here I need to figure out which direction I'm going to shade. So what I'm going to do is I'm going to test a point. I tend to pick the point 0, 0. And if my inequality works for 0, 0, I'm going to shade that direction. And if it doesn't, I'm going to shade the other direction. So here I'm going to test it back in my inequality. So I have 0 is less than or equal to 4 plus a negative 1/2 times 0. So 0 is less than or equal to 4, which is true. So I'm going to shade in that direction. So here I shade. And what I notice as I shade is I have this triple shaded region right in here. So I'm going to make that a little darker. And that triple shaded region here is the one spot where we have points that work in all three inequalities. And that's what we're looking for, is where on the graph do we have points that work in all three inequalities.